So average rate of change. So average rate of change is the slope. That word, slope. You first heard in 7th grade, then you heard in 8th grade, then you heard in Math 1, whenever you took Math 1. That word always comes back. It didn't really appear in last year in Math 2, but it definitely comes back. Average rate of change is a slope, right? Slope, what do you know about slope? Rise over run. The formula, right? The formula here, y2 minus y1, x2 minus x1, that's what we're talking about today, okay? They just call it average rate of change, but it's the same idea, okay? It's the same idea. So what is slope? Slope is any change over time, anything that changes over time, right? Like the most common slope that you guys probably see is when you get in your car, or if you drive, you get in your car, or you're in a car, miles per hour, that's slope, right? If I'm driving down the street and it says 35 miles an hour, miles per hour means something. So if I stay in my car, what that means is if I stay in my car and I keep going 35 miles an hour and I don't stop for 1 hour, I'll be 35 miles from where I started, right? That's what it means. Now, no one does that because you can't really go 35, right? There's traffic, so you slow down, speed up. There's stoplights, stop signs, all that stuff, right? But that's what it means. If you're going 35 miles an hour, if you stayed that way for an hour, you'll be 35 miles from where you started, okay? 35 miles away. That's slope. How many miles have you changed over how much time? That's slope, okay? So that's what rate of change is, average rate of change, okay? So we're gonna need to do two things. First thing we're gonna do is find 2 points, right? Find 2 points, starting and ending, okay? And then we're gonna use the formula that you guys probably have used since elementary school. It hasn't changed, or not elementary school, junior high. It's the same formula, it hasn't changed, okay? So there's 3 things we're gonna see. We're gonna see tables first, graphs second, and then they're not gonna give us any of them. They're gonna give us just an equation, okay? So we're gonna show you examples. I'm gonna show you examples of how to do it, how to do average rate of change in each. So we'll start with table, okay? So table here. Okay, so we got one table, okay? So it says, given the function defined in the table below, so we're going to use the table, find the average rate of change. So there's that word right there. That means slope. Find the slope. In simplest form, remember, slope is always a fraction, rise over run. So simplest form means reduce it if you need to. Okay, that's what that means. Over the interval, 3 to 4. That just says goes from 3, starts at 3, ends at 4. What's in between the 3 and the 4? What's in between the 3 and the 4? Yeah, what variable? X, right? So this is important here because remember, we're looking for 2 points, right? I'm looking for point 1 and I'm looking for point 2, right? They will always give you somewhere to start. They will always give you somewhere to start. Where do they give you the start? Well, these are x's, right? These are x's because they had x there. So the first one, 3, we'll call x1. The second one, 4, we call x2, right? So x1 is the first x in our point. x2 is the second x in our point. So they always give us half. They always tell us where to start. So 3 is going to go here, and 4 is going to go there. It's our job to find the other, the y's that go with it. Well, there's 3 ways. The first way is the table. So what I want you to do is go find when x is 3. What number goes with it? 4. So guess what? This y is 4. When x is 4, what is y going to be? 4 as well, right? Okay, so now we know what point 1 is, 3 comma 4. We know what point 2 is, 4 comma 4. Now we're going to use the formula. Okay, so here we go. They always use M for slope. I don't know why they don't use S for slope, but M is always slope. So whenever you see the letter M, it always means slope or rate of change. So I use parentheses with minus sign because there's always minuses in the middle. The reason I use parentheses is because sometimes you plug in negative numbers. And I want to keep the minus number, the negative numbers, and the minus signs away from each other, right? I don't want to get them confused. Okay, so we plug it in. First one is y2. y2 means 0.2 y. So what is the y for 0.2? 4. So that goes in the first spot. Then we have y1. What is 0.1's y? Also 4. Okay. Now let's go to the x. What is 0.2's x? Also 4, yeah. And what is 0.1's x? 3. Okay. Subtract. 4 minus 4, 0. 4 minus 3. So divide. So it would be positive 1 because 4 minus 3 is just positive 1. 0 divided by 1, ask your calculator, but anytime you have a 0 on top of a fraction, the answer is always 0. So the average rate of change is 0. So what happens if I have a rate of change of 0? What does that mean if I have a rate of change or a slope of 0? Does it move? Change. It moves, but does it change? There's no change over time. I'm going 35. Am I moving? Yes. But am I changing my speed? No. Right? Constant. There you go. Right? Constant. Okay? All right. Okay, let's do number B, letter B, 1B. So the 5 here should be a 6. So change this to a 6. I don't know why it was a typo. So that's 5 down here. It should be a 6. It was just a typo. So again, we're finding rate of change. So we need 2 points. Okay. They always give us some place to start. They always, always, always will tell us some place to start. Okay. So the 2 is our x1. The 6 is our x2. So 0.1's x is 2. 0.2's x is 6. Now we need the y. So go to the table. When x is 2, what is y? 6. When x is 6, what is y? 10. Good. Formula. Okay. We start out with 0.2. What's 0.2's y? 10. What is 0.1's y? 6. What is 0.2's x? 6. What is 0.1's x? 2. Subtract, reduce, you're done. So 10 minus 6 is 4. 6 minus 2 is also 4. Divide those, we get positive 1. This one changes. There's a little bit of a change over time. Okay? Tables aren't that bad. That's why I started with tables. The rest aren't that bad either, but I always start with the easy one. Tables is pretty much the easiest. The next one is graphs. The next one is graphs. Well, isn't a graph just a table with, instead of numbers, it's got dots on it? It's the same thing. It's exactly the same thing. So this is what, do you have to do this? No, but this is what some of my students did last year, and I'm going to show you guys. What they did was, first thing they did when they had a graph was they made a table. They had x and y. And they did each dot. So the first dot, let me use this color blue. The first dot is at, the blue dot here, the first dot is at -7, down 4, right? -7, -4. Next dot is up here. That's at -6, +4, right? Then the next dot was at -5 up 2, -5, 2. Then the next dot was down here. -4, -4. The next dot, -3, -8. Okay, 2 more dots. The next one is -2, -4. -2. And then the last one is at -1. Was that 14? Okay. Do you have to make a graph? Do you have to?
Shouldn't the 8 be negative?
For -3, yes. Yep, that should be negative. Thank you. So do you have to make these for the dots? No. But a student last year showed me this, and they say, I do this. I'm like, that makes sense. So that it's just the same type of problem. Do you, like I said, do you have to make a table for these? No. Each one of those dots represents this, right? So if you can do it without the table, go for it. You don't have to use a table. But I just show it just because, like I said, it's kind of a different way to do it. Because students are always good at the table, but sometimes the graphs, they're not, sometimes it happens there. So, okay. All right, so let's do number 2B or 2A. So it's saying the function y equals f of x is graphed above. So we're going to use the graph. What is the average rate of change for the interval -6 to -2? All right, so again, we need 2 points. Point 1, point 2. They always give us somewhere to start. x1 and x2. They always give you somewhere to start. So x1 is -6. x2 is -2. Now, since we have a table, you can use the table or you can use the graph. When x is -6, what is y going to be? +4, right? Or you can use, it refers to this guy here, -6, 4. When x is -2, what is y? -4. It refers to that dot there. Okay. Formula. Minus. So we start with y. 0.2's y, -4. 0.1's y, +4. 0.2's x, -2. 0.1's x is -6. Good. So we got a lot more negatives here than we're used to. We didn't have any negatives on example number 1. So that's why I used, especially when I use parentheses. So -4 minus 4, is that 0? No, it's not 0. -4 minus 4 is -8. Yeah, be careful there. -2 minus a -6. Isn't that just double negatives here? So it should be -2 plus 6, which is 4, right? Reduce, divide if you can. You can divide these, you would get -2. It's a negative change over time. It means it went down over time. Negative rate of change means something decreased over time. All right. Okay, so do letter B right below it. If you haven't already, do 2B right now. So the place they told me to start, -3 is x1, -1 is x2. So then I went to the table and I figured out that -3 and -8 go together and -1 and +14 go together. So now I got to use my formula. y2, 0.2's y is 14, 0.1's y is -8. 0.2's x is -3, or sorry, -1, 0.1's x is -3. 14 minus a -8 is not 6. It's 22. -1 minus a -3 isn't -4, it's actually +2. And then you divide or reduce and you get 11 or 11 over 1. Okay? That one's a positive change over time. It's increasing over time. Okay? All right, so that's graphs, that's tables. So the last one is equations. There is no graph. There is no table. So what do? It's not visual. What do? Well, we got to make these guys. I need an x and a y for both. Okay? So the first thing is, where do we start? We always start with the 2 points, right? So here we go. We got 2 points. Point 1 and point 2. They always tell us somewhere to start. x1 and x2. So -3, +4. Okay? I don't have a graph. I don't have a table to go to. So I have to use this guy here. I'm going to use this guy here. So what am I going to do? This is what I'm going to do. I'm going to plug in x1 and x2 into f of x. I'm going to show you what that means in a second, but that's what I'm going to do. So start with -3. I'm going to plug in -3 into f of x. So that means everywhere there's an x, I'm going to put a -3. Everywhere there's an x, I'm going to put a -3. Okay? So x squared, I'm going to put parentheses squared. Plus 3x, I'm going to put parentheses for 3, or for x. Now I'm going to plug in -3. And simplify. Order of operations. Exponents first. -3 times -3 makes +9. Then multiplication. 3 times -3 makes -9. Bring down the -1. 9 minus 9 minus 1. Well, 9 minus 9 is 0. That leaves you with -1. So what you did was you plugged in your x1. What you got out was your y1. Plug in your x1, you get out your y1. So we're going to put -1 by the -3. Okay, I'm going to do the same thing for +4 now. I'm going to do the same thing for +4 to find that y value. Parentheses squared plus 3 times parentheses minus 1. So this time I'm going to plug in 4 because that's my x2. So plug in 4 everywhere there's an x. Order of operations, exponents first. 4 times 4 is 16. 3 times 4 is +12. Minus 1. 16 plus 12 is 28. Minus 1 is 27. That's your y2. Okay, so you got to do a little bit of work to get your points, but once you get your points, you're going to do exactly the same thing. Step 2, use your formula. Here we go. M equals 0.2's y is 27. 0.1's y is negative 1. 0.2's x is 4. 0.1's x is negative 3. 27 minus negative 1 isn't 26. It's actually going to be 28. 4 minus a negative 3 isn't positive 1. It's actually going to be positive 7. Divide, you get 4. Okay. All right, so we're going to do example number 4 together. And then I'm going to give you one more problem to do on your own, and then we'll be done. Okay, so you're going to do one more problem after we do this one. After we do this one, you're going to do one more problem on page 21 before you tape in, okay, in your notes. So we're going to do one problem together, one problem, then you'll do one problem on your own. Okay, here we go. Number 4. Okay, again, we do not have a graph or a table, we have a function. So I'm going to use my function for my points. So point 1, point 2. Always give you somewhere to start. x1, x2. Don't have a graph, don't have a table, plug them into your function. So the first thing I'm going to plug in is negative 4. So f of negative 4, be careful when you plug it in. I'm only plugging it in for x. Everything else stays there. The negative in the front, the negative in the front, or in the middle, those all stay there. So you're going to have negative parentheses squared minus parentheses plus 3. Be careful. Because that I've seen that cause some issues too. Okay, negative 4, negative 4. So we do exponents first. Negative 4 squared is negative 4 times negative 4, positive 16. But then you also have the negative in the front. That negative is really a negative 1. Same thing with the negative 4. Now I'll multiply. Negative 1 times 16, negative 16. Negative 1 times negative 4, positive 4. Plus 3. Negative 16 plus 4 is negative 12. Plus 3 is negative 9. So I plugged in my x1. I got out my y1. Okay, 6 now. So I'm plugging in 6 now, because remember, 6 is my x2. Not x squared, x sub 2. So negative 6, negative 6. So remember, there's negative 1s in front of the parenthesis that we don't write. So I get negative 1. 6 times 6 is 36. Negative 1 times 36 is negative 36. Negative 6 times negative 1 makes positive 6 plus 3. And I get negative 27. Make sure you guys Don't take my word for it, because sometimes I'm doing this fast, and I've made mistakes the last 2 classes. So if I make a mistake, let me know. Did I make a mistake somewhere? Which one?
It's a positive 600.
Yeah.
Oh, I plugged in. Why did I plug in a negative? You're right. This is supposed to be a positive 6. Yeah. Sometimes I go too fast and I do that, so please check. So this is going to be a negative 6, right? So what is that? Negative 39? Okay. So yeah, always double check me, because sometimes I do too fast. Okay. Okay, so last thing is formula. Y2 is what? 0.2 is y, negative 39. 0.1 is y, negative 9. X2, 0.2 is x. 0.1 is x. Double negatives, double negatives. What do I get? Negative 30 over 10. Negative 3. Okay. All right, so go to page 21. I'm going to give you one problem, just one problem to do. I want you to do it on your own. Try it on your own. Then we'll be done. Okay. All right. So your first point is negative 3,5. Your second point is positive 4, negative 23, because I had to plug them into the equation. Remember, the negative in the front stays in the front. Okay, don't mix it with the number you're plugging in, or else it'll give you a wrong answer. Okay, and then I plugged it into my formula, y2 minus y1, y2 minus y1, x2 minus x1, had double negatives on the bottom. divided, and you got -4. Okay. All right. Let's tape those into page 21.